I'm Bhavna Bindal from Binary Semantics Limited, and it's my pleasure to welcome you all in this webinar. Today, we all are working in complex as well as multidisciplinary scenarios. And for developing such projects, we require to work in an efficient way. Efficient way in the sense where we are able to do things where minimum rework is required, as well as we are able to detect errors in the very early stage. And for interdisciplinary projects, we can communicate at each and every step so that the objectives of the projects are fulfilled. For the same, we can use MBSE technology, that is model-based system engineering technology. Today, we have organized this webinar on systems engineering connected for rapid and error-free integration of system engineering knowledge into systems model. Today, we are having with us our speakers, Mr. Paul Goossens, who is Vice President of MBSE Solutions at Maplesoft, Bahrani Mohan, who is Product Manager of MapleMBSE. We have also invited Mr. Mudit Mittal, who is Technical Director of BlueKei Solutions, who are working towards implementation of MBSE. So let me give a brief introduction about Binary Semantics. Binary Semantics is a 35 years old company which is headquartered in Gurgaon. We are having technical expertise in cloud and mobility, product engineering, BI and analytics, machine learning, and digital transformations. We are working in various industry verticals ranging from BFSI, text technology, insurance, transportation, and logistics. We are having certifications 27001 and ISO 9001. We are technology partner to firms like Microsoft, IBM, SES, Oracle, and Maplesoft. And we are having a huge client base, which includes companies like Aditya Birla, Mahindra, Tata Motors, Jindal Groups, and various others. We are currently present in various locations in India, from Gurgaon, Mumbai, Bangalore, Hyderabad, and many others. If we talk about our product and services, so our homegrown products include Visoft, that is an automotive OEM used by more than 99% of automotives in India. GST Robo, that is a complete solution for GST return filing and billing. It can produce all sort of e-invoicing and e-way bills. We are having Fleet Robo, that is a fleet management software that can be used for tracking all fuel as well as workforce management and trips management. In BI and analytics, that is data analytics group, we are providing various business analytics and intelligence softwares, various risk analysis, quality analysis, optimization software. Here we are also working with mathematical analysis, and we are providing products from Maplesoft, including Maplesoft, MapleSim, MapleLearn, and MapleFlow to various esteemed colleges like NITs, IITs, and also to research institutes like ISRO and DRDO. We are also working in product engineering and providing program management solutions. So before we move ahead, let's have a quick poll to know about our audience. So can we have the poll? Okay, so this is the poll where you just need to enter from how long you are using the MBSE in your organization. Are you very new? Are you thinking about it, or you are planning to use it? So we'll have 1 minute time to get the answers. Okay, now we can stop this poll and get to the results. Okay, so we can see that our audience is ranging from various, some of them are using it for more than 5 years. We are having some audience who is using it for 1 to 5 years, and some are still thinking and planning. So for the same, we are going to enlighten about what is MBSE, how it is useful, and how you can actually use it in your day-to-day curriculum, or how it will be helpful. So let's call our speakers, Mr. Mudit Mittal, for sharing about MBSE and its importance in various program management.
Hello.
Yes, Mudit.
Okay. Sure. So shall I start sharing?
Yeah.
All right. Okay. So good morning, everyone, and welcome to this webinar. So I'll be talking about how MBSE is an enabler for digital engineering. For that, I'd like to quickly talk about our company, BlueKei Solutions. So we are a digital engineering consulting company, and our motto is to empower organizations in transforming engineering development and systemic understandings. The way we work with is we partner with various organizations in the form of consulting or project execution or competency development. And we strongly believe in the digital engineering and system engineering capabilities. If you look at our expertise, we have different experts on board with overall, I would say 70 plus years of onboard experience in the system engineering deployment combined together. And we are currently working with various organizations cutting across various industries like aerospace. We are working with automotive very heavily, manufacturing, drones, and other manufacturing and industries. So that's a very, very quick overview. And I would like to now go into really the digital engineering and model-based system engineering aspect. So just to trying to catch up about what is happening, I would like to start with all the exciting stuff in the field of technology, in the realm of technology that is happening around. And here I have few screenshots of the latest news from automotive industry. So for example, this one I just came across yesterday, wherein Mercedes-Benz is offering hands-free traffic jam assist in the US this year. So most of you would know that the automotive industry is moving towards not just electric vehicles, but also towards autonomous driving. Of course, this sort of was very much influenced through Tesla, but now many big players are jumping into the same. And we can now see examples of such hands-free driving, especially in few cities in the US, wherein people are using them as taxis. Another example here is from GM. They are offering something called as Ultra Cruise, which is again talking about hands-free operation and autonomous driving. Third one that I just came across was Kia is planning to invest a lot of money into electric and self-driving cars, SUVs and trucks and more. So let's see what that is. And this is more about the automotive, but we all are aware about also about SpaceX, about the Falcon landing. So the image on the right side shows how Falcon lands on its own, right? So imagine the control system that is going behind this and the level of system engineering that has gone behind this. Another example that I would like to just bring to your notice is this. This is again taken, I just pulled it off from Twitter. This is talking about the software that goes inside Tesla that is enabling the autonomous driving. And this visualization over here is showing how the car is actually seeing the world, right? And the level of detail that they are capturing at this point. So one thing that we can simply, understand from all of this is how software is becoming a very, very important role in the digital engineering aspect, in the overall product development aspect. And this is not just about building the software, but also using software to build our products, right? So it's both of those aspects that we are looking at. Few more examples that I want to talk about are actually in India. So for example, this is the network of the Delhi Metro and how over the last 15-20 years, it has cut across multiple states. You can go from Gurgaon to Noida within Delhi into the deepest cities, deepest areas, Chandni Chowk in Delhi, and just come up, in the busiest of places. So such kind of feat has been achieved through these engineering marvels. And we are I would say lucky to be a part of all this change in this world that is happening. Another example is the drones, and you might have also come across how government is now supporting drones. The image on the right side shows the latest news wherein the drone Shakti mission has been launched, right? And lot of new technologies, lot of laws that are enabling a lot of small players becoming big, right? So drone industry especially has been driven through startups, and they are coming with not just different kind of applications, agricultural applications. They are going for drone-based delivery applications, right from small packages to huge consignments across the cities. So all this, right, all of this is happening through different engineering aspects. And I would like to now bring in how this is happening and what is happening. So digital engineering, as you can see, is actually a key enabler in all of these complex, all of these exciting projects. This image from NASSCOM talks about the two phases of digital engineering. The one on the left talks about the type of digital products that are being manufactured or being deployed. So we are now seeing a lot of new products, business models turning as service, right? So you are able to see products as service, cloud as service. A lot of things are coming as service, and all of that is being enabled by intelligent solutions, IoTs, connected networks, cloud technology. So which is the customer facing. Now, what is happening at the back end is how are we enabling this technology? So that aspect is called the digital engineering, wherein you will see that there's a traceability across supply chain, there's AI-enabled processes, there's virtual simulated engineering into the place, 3D printing, predictive prescriptive maintenance, right? So we're talking about a digital twin, a digital engineering aspect, a complete thread that is tying from your left side of the V to the right side of the V. And the V that I'm going to talk about is actually the whole life cycle stages of product development. So what I have here is system engineering V. It has been in practice for almost 30 years now. What it simply talks about is that a product goes through various life cycles, right? Different stages across this life cycle. You start from top left, wherein you have your regional architectures, you do your feasibility study, you look at concept of operations, and then slowly you start understanding the problem space, and then you go into the solution space. The solution space talks about the system requirements, the high-level design, the detailed design, and then you eventually deep dive into the different design aspects like the software, hardware, if you're talking about network or mechanical, hydraulic. So all those design happen, and then integration starts to happen. And that is when you start moving towards the right side of the V. The right side of the V is where you have the integration, validation, verification, and of course, deployment. And then you also plan for the retirement of the product. So this whole life cycle can actually be broken down into these stages: the concept stage, development stage, production stage, utilization stage, support stage, and retirement stage. And what is happening in all of these stages are that initially we were doing a lot of document-based engineering or document-based systems engineering, right? So all the requirements were captured in documents. 30 years back, the drawings were done, hand-drawn CAD drawings were done. Hand-drawn mechanical drawings were done. Now that has transitioned to CAD drawing. The testing that was mostly physical tests are now being converted into hardware in loop, software in loop, or virtual validation tests that are getting imbibed in the technology. So this diagram from Incosys System Engineering Vision 2035, it's a great read, I would encourage, talks about how these steps in the whole life cycle happens, and then how digital engineering is playing a key aspect in enabling all of this digital thread. So there is going to be an enterprise digital thread that walks you from the left side of the V to the right side of the V. And then you have all of these implemented across different tools that are being utilized by different people at different roles within one organization or within a conglomeration of organizations. Another aspect is This is also called as the model-based engineering diamond. This concept was introduced by Boeing in 2020, where they talk about that you are following the traditional V, but then as per the document-based V, you also have a similar mirror on top, which is your virtual V. So whereas you are doing your typical design process or your typical delivery process, you have modeling and simulation to support that. Now this V or this diamond actually cuts across from top to bottom as well as left to right. So for example, you might even models for virtual support. All of this is happening, and this together actually forms your digital twin. Just like it cut across from top to bottom, it is also cutting across from left and also towards the right side of the V, right? And maybe I'll just skip a few. This together actually is enabling your digital thread. And another important aspect to look at is these models and virtual models and virtual simulations are helping us achieve sort of 2 or 3 primary objectives of any manufacturing organization, which is reduce time to market, right? Also, first time right. What it means is if you are able to validate it thousands of times in the virtual world and fail there fast, but in the real life, you are actually able to produce it right the first time. You have actually reduced your overall life cycle, shortened your duration of time to market, saved a lot of cost on errors, and you have actually ahead of the game with the competition. And that is what is enabling the use of model-based engineering. So talking about model-based engineering and model-based system engineering, which is sort of the key topic for today. This is how actually model-based design in general, which is the overall MBE, encapsulates the MBSE aspect. So we see MBSE as a centerpiece wherein you are talking to model-based design, you're talking to model-based software development or model-based manufacturing or model-based testing. So all of those things are happening today virtually. Depending upon the organization and depending upon their need, they are using these things in bits and pieces. But we are seeing a trend now in almost all major OEMs where they are moving from document-based engineering to model-based engineering. And all of this is happening with MBSE in the center. And I'll talk about what is MBSE in the next slide. So MBSE, as you go by definition, is basically a formalized application of modeling to support system requirements, design, analysis, verification, and validation, and cutting across the life cycle of the phases. So basically, it's a formal method wherein you are using modeling and simulation to really adopt systems engineering. That is sort of the simplified version of MBSE. Now, MBSE, as of many people know, you might have also heard the term called SysML, right? Which is a very, very common language to really start your MBSE journey. But what happens is that language, that SysML or UML, any of these languages are actually one of the 3 pillars of MBSE. You really need methodology, you need language, and a tool to support both the methodology and the language to really enable MBSE. And one of the core languages, which is very common and has now sort of become a standard, is SysML language. SysML language stands for System Modeling Language, and ultimately a language is providing you semantics and notations. So the idea behind a graphical language is you are able to denote your concepts of system engineering, your artifacts, such as context diagrams, such as behavioral models or architecture or requirements or any test cases or parametric analysis in terms of diagrams, which anyone can understand because they all are using the common language behind. So they're using the same notations at the back end that will help anyone in the world understand, irrespective of which tool you are using. So in a way, SysML becomes tool and methodology agnostic. Now, the methodology piece is often driven through the organization's culture, their product development process, but also sometimes adopted from the best practices across the industry. So one of the most common way of looking at methodology is approaching it from black box and white box perspective, wherein you drill down to the problem space, understand what is the mission that you're trying to achieve, and then you go down into the solution space. All of this problem space, solution space can be broadly categorized into these 4 pillars, which is also the 4 pillars of SysML. You can represent the system engineering artifacts in form of structure. So an example of structure would be your architecture, your logical architecture, your physical architecture. It could be the context diagram, right? It could be the bill of material that you want to represent. All of that represents the structure of the system. The behavior is what the system is doing. So the behavior is represented again by different formats, by different diagrams, such as activity diagrams, sequence diagrams, state machine diagrams that many of you might already be familiar with. Those are what is represented as the behavior. And then you have requirements and parametrics. All this together is stitched together and forms a traceability end to end, right from the left side of the V to the right side of the V. Some examples. I won't be able to go deep dive into an actual case study, but this is an example that we have taken for a smart parking system that was done at Incose, India. Here we represent activity diagram talking about the behavior of how a user is going to use an actual parking lot, right? So this also represents a very, very high level operational scenario. The bottom diagram represents the structure or the high level architecture of a system and how requirements are being satisfied by those elements. So what you're doing here is you're building a traceability of, okay, this is my system requirement and this is how my system is actually satisfying my requirements. So you're also looking at a requirements coverage. This will actually help you not only in early verification and validation, but also in your certification, because many safety certifications look at the completion or the complete coverage of requirement. So at the same time, you're also satisfying all your certification needs. The top diagram over here represents a matrix format of the overall architecture. So this is a DSM talking about what are the system interfaces and how are they talking to each other. So there are several views that can be automatically generated out of model-based system engineering tools. But what feeds into is really the 4 pillars. You really define the behavior, the architecture, the requirements, and the parametric. If you look at overall, just trying to conclude on the digital engineering aspect, a system engineer actually has to partner with machines, right? And when we talk about machines, we are talking about the enablers of product engineering. So for example, your computers, but it is now not only limited to computers, but you're also interacting with the test setups. You are interacting with prototypes. You are interacting with immersive visualization, right? So a lot of new technologies are coming into the game. You're also looking at machine learning and AI enabling systems engineering. So there's a concept of SE for AI and AI for SE. All of this is coming together. And at the heart, you actually have models and simulations. That is what your MBSE is. And this is how MBSE is tying the world together of digital engineering. If I quickly summarize what are some advantages of MBSE adoption, one of the biggest use case for MBSE adoption would be reuse. Once you have done it once, you can easily reuse your models, you can easily reuse your library components for the next project or for your next product cycle. It reduces errors because in traditional way, and this is, we have seen many pain points of our customers, wherein they are doing maybe architecture in one tool and they are doing design in another tool, and those tools are not, right now not talking to each other. But slowly, the adoption of MBSE is actually enabling this interoperability, wherein you can take data from one tool and move it to the other tool, and you're able to reduce those errors because all of this is happening automatically, and it's no longer dependent upon just on a human brain. It enables communication. So once you have these views created, it helps you communicate with all the stakeholders. Across the lifecycle, you're able to model, right, from the left side of the V to the right side of the V. And then, since this is a computer-readable language, a computer-readable model, you can actually do automated reasoning. You can do a lot of algorithms on top of your models that can give you a lot of analytical results. And a lot of research is happening in this field. Ultimately, what is happening is it is narrowing the risky and expensive gap between describing a design and analyzing it, because again, the tools are interconnected and your design can easily be fed into virtual validation and verification. Two more important points that I would like to talk about is decision making, which is probably, this is how it starts. You are able to take decisions because you have modeled everything and now you can do analysis on top of it. And also you can manage the complex architectures. Right at the start of the talk, Bhavna mentioned how all the technology, how the products are getting more and more complex. All of these complex architectures can now be managed using MBSE. And finally, I would like to talk about, before I hand over to Paul, how MBSE is actually a critical enabler. So right back to my topic for the day. So once you have all of this set up, MBSE can help system engineers to be consistent across product development lifecycle. And as I mentioned earlier, through the traceability, through the interoperability, it actually becomes a centerpiece around the overall digital engineering aspect. And you can actually exchange a lot of information across. And then it can also connect you to architecture and any other test case management tool or bill of material tools. And finally, through this methodology, you're actually bringing a rigor and concordance between these various stakeholders. Not just the stakeholders which are customers, but stakeholders of the program such as marketing, business stakeholders, test engineers. All of them can be brought together and they can achieve much better results much faster with reduced errors. So with that, I would like to thank you all and hand it over to Paul for the next talk.
Thanks a lot, Mudit. Okay, is everybody seeing that? My screen? I can see your screen. Okay. You now get a little notification saying that everybody can see my screen. That's great. Okay, well, thanks very much. And that really does set the scene for our part of the presentation very well. And certainly, we are very excited to be working, both with our longtime partner, Binary Semantics, and our new partner, BlueKei, and in terms of advancing, the role of systems engineering within the Indian industries. We are actually going to be presenting something that really, has proven to help in increasing the chances of success in implementing implementing an MBSE process. I'm actually presenting this with my colleague Bevarani, and I'm just going to give you a little bit of an introduction to what this tool is all about, and then we'll take you through a demonstration of the tool. So what MapleMBSE is actually doing is it's providing a means of connecting all your various engineering processes and all of the various stakeholders that need to feed their information for the task that they're working on to the systems engineer through the systems model. So Mudit talked about the SysML model, which is capturing all the sort of four pillars of the system definition. But the systems engineer needs information from the various subgroups that are involved in the design process. Typically, these people will be called subject matter experts. They're the ones that have the knowledge to be able to provide that level of information that's required for the systems engineer to do their job to build a successful systems model. And really what our tool provides is the ability to help in providing that information from all the stakeholders in a consistent way. And also in many respects reduces resistance. There's typically a resistance by various people to new tools and new processes, because all we are asking to the SMEs to do is to use Excel to do their work. And with Excel at the front end, at the back end, we are then converting the information that goes into the Excel front end into the systems model in a consistent way, and in the way that the structure, the way that the systems engineer requires it. Well, this isn't just about improving the workflow, the data flow between the SMEs and the systems engineers. It actually means that everybody can collaborate much more effectively through the systems engineer, so they can all capture their knowledge and share it, and collaborate with between all the stakeholders. So it really does help to not only smooth out the process, it actually does allow that increase in knowledge and make that knowledge available and readily shareable. And really, at the end of the day, what this is doing is reducing project risk and any budgeted costs and project overruns. As you can imagine, if you're doing this in a very manual way, errors can start creeping in, miscommunications start to create sort of friction within the process. So a lot of that gets mitigated and actually does reduce the risk to the project. And really, that is really what this tool is all about. So how do we do it? Well, MapleMBSE is essentially a backend to Excel. It has a tight integration with the systems model. So we extract information from the systems model to create a specific view that's going to be used by the end user to perform whatever task they need to do. And then any information that's added to the this view is then sent back to the systems model in the structure and at the level of detail that's required to go into the systems model. So it actually bypasses any need to go through the other systems engineering tools. Everything just happens seamlessly in that way. We're using a familiar interface to allow the end users to put their knowledge into the tool. Everybody's comfortable with using Excel. So as one of our users said, why should we force our end users to be using other tools to do this when the Excel can actually be used to do that? Obviously, because there are many different tasks and many different configurations that need to be performed, we provide a very powerful technology for customizing the front end and the back end in order to do that integration. So it's very quick. I mean, typically it takes about, for some of our end users, takes them between, say, half a day and a day to configure an application using our configuration tools. And we currently we integrate with models that are developed using some of the bigger SE platforms, IBM's Rhapsody, Magic Draw, Cameo through Teamwork Cloud, and then recently last year we introduced an integration with Capella. And just to give you a sense of what it's good for, I mean, these are the typical use cases that we get involved in. And really what it comes down to is when you have large amounts of information that need to be collated and structured and then integrated into the systems model. And these can be things like interface control documents, can be variant management, safety analysis, many different applications, and these are typically performed already being performed using spreadsheets. So there is no cultural shock for the end users. They're already in a tool that they're comfortable using, so it's a very simple step to go to use our tools in order to do their work. And again, it's typically this will be information that is required at a certain level of detail that cannot be acquired, can't be acquired any other way. You need the subject matter expert to provide that that level of knowledge and the level of detail that needs to be used to create actionable tasks within the systems model. We mentioned as an example functional decomposition. That's actually the example that we're going to be showing in a moment. And in fact, we also have systems engineers who are using the tool for doing things like analyzing the structure of the systems model, so they can get a very clear tabular view of the system and actually perform analyses like design structure matrices and traceability analysis. So this is just giving you a sort of a snapshot of the kinds of applications that the tool is being used for. So that's just to set the scene. What we're going to show you is Barani and I are going to play different roles. Barani is going to be the systems engineer. So he'll be driving Cameo and setting up the model and the view that I will be using as the design engineer to provide detailed functional decomposition that will then be added to the systems model. So while I'm getting myself set up, Barani, if perhaps you can share your screen and just take people through what we're actually going to be doing with this.
Yeah, thanks, boss. Should be able to see my screen now. Okay, so for today's use case with MBSE, what we will see is we will see an aspect for functional decomposition. So functional decomposition is nothing but you identify the functions that you expect your systems to do, and also how the system has to perform these functions. If you remember from Mudit's B diagram, on the left side, you usually starts with some requirements, and then you define the high-level definition for the system, and then you further break it down into more detailed information of the system. So for this specific activity, what we will see is we will see the behavioral aspect of the system. So as an example, let's consider activity tracker. So the main function of the activity tracker that you would expect is, say, to identify the steps that you do, what would be the heart rate, you want it to display notification, connect the data to your phone, and etc. So in terms of functional decomposition, what is expected from a user is you want to identify functions from a requirement that is already defined. So this requirement could be from your technical requirement documents or your system requirement document, etc. So you identify the key functions, then you break down the functions or you decompose the function into more lower level. So you get into more details to a level called as a basic function. So what a basic function is, you will be able to allocate this function directly to certain component, or you will be able to relate it to certain requirements that define the function in a very consistent manner. And then what you do is you identify what will be the input for the function or what is going to be the output. And then you allocate these function to certain components that is going to carry out the function. And you do the verification now. So you kind of see the V propagating here, like you start with the high level requirement, you break it down, and then you allocate it to the system. And finally, you do the verification, which is kind of on the right side of the V. So what you will see for the functional decomposition with MapleMBSE is we're going to perform the same thing, but in a more high level. So what Paul will be doing is for us, he's going to identify some system function. Then he's going to decompose the system function into sublevels. Then we'll be able to relate it to requirements. We will allocate it to certain components and so on. So so that will be role of Paul. And then once Paul make the changes, he saves his changes to the system model. I'll be opening it and we will review the model, like what are the new additions that Paul made, how are these information captured in a structured format. So before I move it to Paul, so here I have the model that's open with a modeling tool. So this is Cameo Systems Modeler. You can see that I opened the activity tracker. there are already certain functions that defined in the model, relations to requirements and so on, as you can see. So I have created a template for Paul to capture his knowledge of the functions for the specific system, which is the activity tracker. So he's going to identify the functions, make the relations, and then we'll get back to Cameo to see how he has added the information in a very structured format and how we are able to capture it. Yeah, Paul, you can share your screen now.
Yeah. Okay. So those of you who are familiar with Teamwork Cloud are probably familiar with the login dialog. So I'm connecting to Teamwork Cloud. It's on a remote server somewhere, so somewhere in the world. And here we can choose whichever model we want to pick up. We're working on the activity tracker, and click OK on that. No. Okay, so now we're loading that model that Bharani just showed you. Takes a little while to come in, and also, as Bharani mentioned, I'm using a configuration and a template that he's developed in order to do this task. First of all, just what we have are 3 tabs which are related to the 3 tasks that Bharani showed in his presentation. So we're going to first of all assign functions to fulfill the requirements that are resident in the model. We're then going to break down those high-level function into its more detailed sub-functions, and then we will then allocate those functions to different components within the design. So let's start with the assignment. So these are already residing in the systems model that Bharani showed. So they've already created a view with that information. So what I'm going to do is just add another function here. I'll just put a track steps into here, and I'll hit enter. And you can see that we now have a new row, new column set up against the rows for the different requirements. So the track steps is going to be the function that's going to be fulfill the track steps requirement. So I just simply check that off, and then that relationship is then being applied in the background. So once we've done that, I can now start to decompose that high level function. And again, we already have some functions that are residing in the model. The track steps, that's the one that I've just entered. And you also see that not only do we have a list of the functions, but we also have the hierarchy that these are related to. So I'm going to build a set of new functions that are sub functions to that track steps. So the way I do that is just to create a new row. It's asking me for a task to go in here. So I'm going to start with find. We're going to just use the find the altitude. And we'll do a couple more here. So track steps, and we'll find pressure. And then we can also do the deeper levels of hierarchy. So we could have let's say send data to processors, and right one. No, it's not. Determine activity. Sorry. And then we can then say, okay, I want to add to that send data to processor. Okay, so now I've created these different functions that are all keeping the relationships together. I'm going to put one more in, which is to store the data. Okay, so now it's just, it's simply just adding in the different breakdowns of the functions, but knowing that you're maintaining the hierarchy between the high level function and the lower level sub functions. And not only that, I mean, before I go any further, I think, oh, hang on a minute, that track steps function is actually a sub function of the track daily activity function. So I need to put that hierarchy in. So I'll create a relationship between that and track steps, and then all the other functions are then connected together. Once I've done that, I can then assign these two different components. So, so for example, the track steps is going to be part of the 3-axis accelerometer. The find altitude is going to be part of the pressure. Oh yeah, pressure sensor. Determine activity, that's going to be a function in the processor application. Send data to the processor, that's going to be part of the processor subsystem. And the store data, that's going to be the part of, going to be assigned to the storage unit. Okay, so with a few entries in the spreadsheet, I've now created all those relationships. Now I want to submit those changes into the systems model, and I just fire up my commit button, and I'll put something in here. Track steps decomposition, and hit OK. And those changes are now submitted to the systems model in Teamwork Cloud. So that should then be back to you, Brownie.
Okay, so you can see that I get a notification that the model has been changed. So I'm going to update my project to see the latest changes. You can notice, like here from the list of activities, the new function that Paul added, track steps, they are not added to the list yet. So I'm going to update my project so that we get the latest changes. So the update is now done. You are able to see like a list of new functions that were added, like the track steps, find altitude, the pressure, and so on. To make it clear, I'll just create a new diagram so that we can just visualize the new content that was added to the model. So we had the change to the daily activity, then to the steps, pressure, the altitude, then store data and send data to processor. So here you can visualize the top level activity, then determine activities here, then the store data, find altitude, and everything like in a proper hierarchy that is needed. You can also notice that nowhere when Paul made these changes, like he didn't mention that this has to go into the activities or the kind of relation that has to be created between the activity and so on. So I've already predetermined the template to create where the scope, like where the information should go into the model and what kind of relation should be created. So he also made the relation between the requirement. So you can see that the track steps, you can trace it back or you can relate it to the requirement from which this was refined. And then we also made some allocation to the accelerometer, the pressure sensor, to the processor subsystem application, and so on. So if I just drag and drop the information here, you're able to see the allocation relation. So these are all the new functions. You can see how the functions are being related to each other. So you can kind of do the complete traceability that. So this track steps was from the requirement, and it was further decomposed, and all of the decomposed function, you can see that, for example, the find altitude activity is allocated to the pressure sensor, the processor data is allocated to the application, and so on. As a system engineer, I could review these changes. I can make some changes here and then send it back. So Paul will be able to see the latest addition. So for example, as my review, I find that like say, send data to processor is not right because this is being allocated to the application. So I'm just going to rename this as send data to processor application. And then I'm just going to save my changes back to the server.
Okay, and I'll just share my side.
So
add-ins. You submitted now?
Yeah. So you can go into one.
Okay, so now I'll just reload. Okay, now we can see the change that's reflected in here. So everything is seamlessly integrated into the workflow. And I've noticed we're running a little short of time, so I think we'll cut it short there.
So thank you so much, Paul. Thanks, Mudit, for a wonderful session. I hope this is really insightful to the audience. Also, thank you so much, audience. We will also share you the recording of the session to the attendees. And any query, any doubt you do have, you may bounce back to us on the same mail ID. Thanks everyone for joining us. Thank you so much. And for any sort of query related to MapleMBSE, Maple product, you may reach to Bhavna. Bhavna, if you can highlight the mail IDs, and for any services consulting related support on MBSE, you may write to Mudit. We'll share those mail IDs over the recording also.
Okay, that's great. Okay, well, thank you very much, everybody.
Yep, thank you so much, everyone.
Thank you.
Thanks, everyone.
Bye.
Bye.